Hi, I am Teacher Daisy. Now, let's learn Form 5 Chapter 2 Matrices. In this chapter, you will learn 2.1 matrices and 2.2 basic operations on matrices. First, let's us understand what is a matrix. A matrix is a set of numbers arranged in rows and columns to form a rectangular or a square array. A matrix is usually represented with capital letter, such as A or B, and written in the brackets or square brackets. Matrix can be used to represent the information from real situations. Example: represent the following information in the form of matrices. A. The table below shows the recommended daily calorie intake for females by category. Solution: we can represent the table with a row matrix, which has only one row. Or represent with a column matrix, which has only one column. Example: B. The table below shows the medal collection of Malaysian contingent for 3 events in the 29th SEA Games. Solution: we can represent the table with a square matrices, which have the same number of rows and columns. Order of a matrix. Matrix with m rows and n columns has the order m by n and is called as matrix m by n. For instance, this matrix has 2 rows and 3 columns. So it is a matrix with order 2 by 3 and can called as matrix 2 by 3. Elements in a matrix. Every number in the matrix is known as the element of the matrix. Each entry or element is shown by a lowercase letter, with a subscript of row and column. In general, the element at the I row and j column in matrix A is represented as follow. Example: given that matrix D, determine A. the order of the matrix, B. the elements D11, D21 and D32. Solution: A. the order of the matrix is 3 by 2. B. D11 equals -2. D21 equals 0, and D32 equals 9. Determine whether 2 matrices are equal. 2 matrices are equal if and only if both the matrices have the same order, m by n, and each corresponding element is equal. Example: determine whether each of the following pairs of matrices are equal. Give your reason. Solution: A equals B, because both the matrices have the same order and each corresponding element is equal. B, C does not equal D because both the matrices do not have the same order. The order of C is 1 by 2, while the order of D is 2 by 1. C, E does not equal F, because the corresponding elements are different. Example: it is given that matrix P and matrix Q. Determine the values of X, Y and Z if P equals Q. Solution: P equals Q, hence all the corresponding elements are equal. X equals 5. 7 equals Y plus 1, Y equals 7 minus 1, equals 6. 5 minus 3z equals 2z, 5 equals 5z, z equals 1. 2.2 Basic operations on matrices. In this part, we will learn addition, subtraction, multiplication and inverse of matrices. Addition and subtraction of matrices. These can only be performed if the matrices are with the same order. Each corresponding element is added or subtracted to obtain a single matrix with the same order. Example: Determine whether addition and subtraction can be performed on the following parts of matrices. Solution: A. No, because matrix A and matrix B have different orders, so cannot perform addition and subtraction. B. Yes, because matrix C and matrix D have the same order, so can perform addition and subtraction. Example: it is given matrix C, D, P and Q. Calculate A, C plus D, B, P minus Q. Solution: A, C plus D. Add up each corresponding element. B, P minus Q. Subtract corresponding element. The laws for addition and subtraction of matrices. Addition of matrices obeys commutative law. A plus B equals B plus A, but subtraction of matrices does not obey the commutative law. A minus B does not equal B minus A. Addition and subtraction of matrices obeys the distributive law. H times A plus B equals H A plus HB. H A minus B equals H A minus HB. Addition of matrices obeys the associative law. A plus B plus C equals A plus B plus C. But subtraction of matrices does not obey the associative law. A minus B minus C does not equal A minus B minus C. Multiplication of matrix by a number, scalar multiplication. It is done by repeated addition of the matrix. If matrix A is multiplied by a number n, then matrix A can be added up to the same matrix A repeatedly for n times. Each element in matrix A is added to the same element repeatedly for n times. Multiply every element in the matrix with the number. N is known as the scalar, which means constant. Example: given that matrix D. Calculate A, 3D, B, negative half D. Solution: A, 3D. 3 times every elements in the matrix D. B, negative half D. Negative half times every elements in the matrix D. Example: given that matrix D. Calculate the values of x and y. Solution: do multiplication of half first. Then do the subtraction. After that, by comparing the value of left-hand side and right-hand side of the equation. 2 minus x equals 5, x equals 2 minus 5, equals negative 3. 6 minus negative 3 equals y. Y equals 6 plus 3, equals 9. Multiplication of two matrices. If matrix A has an order of m times n, and matrix B has an order of n times p, then the multiplication AB can be performed, and the order of AB is m times p. The number of columns of the first matrix must equal to the number of rows of the second matrix. And the result will have the same number of rows as the first matrix, and the same number of columns as the second matrix. Example: it is given that matrix C and D. Determine whether multiplication CD and DC can be performed. If yes, state the order of the product of the matrices. Solution: multiplication CD cannot be performed, because the number of columns in matrix C is not the same as the number of rows in matrix D. Multiplication DC can be performed, because the number of columns in matrix D is the same with the number of rows in matrix C. The order of DC is 2 times 1. Example: It is given that matrix A and matrix B. Calculate the matrices AB. Solution: the first row of the first matrix, multiplied by the first column in the second matrix, 2 times 6, plus 3 times -2. The first row of the first matrix, multiplied by the second column in the second matrix, 2 times -7, plus 3 times 1. The second row of the first matrix, multiplied by first column in the second matrix, 1 times 6, plus 5 times -2. The second row of the first matrix, multiplied by the second column in the second matrix, 1 times -7, plus 5 times 1. Equals 6, -11, -4, and -2. Example: the local shop sells 3 types of pies. Apple pies cost Rm3 each, cherry pies cost Rm4 each, blueberry pies cost Rm2 each. The amount they sold in 4 days is as follow. Calculate the value of sales for Monday. Solution: the dot product of prices and how many were sold. Rm3, Rm4, Rm2, dot 13, 8, 6 equals Rm3 times 13, plus Rm4 times 8, plus Rm2 times 6, equals Rm83. Therefore, the sales for Monday is Rm83. Matrix multiplication is not commutative. AB does not equal BA. You can see by the following example, the result of AB and BA are different. Example: calculate the values of x minus y. Solution: multiply the matrices. First row of the first matrix, multiply by first column in the second matrix, 6x times 2, plus -5 times 1. First row of the first matrix, multiply by second column in the second matrix, 6x times 3, plus -5 times 4, equals 12x minus 5, 18x minus 20. Comparing the corresponding elements, 12x minus 5 equals 7, 12x equals 12, x equals 1. 18x minus 20 equals 1 minus y. 18 times 1 minus 20 equals 1 minus y. -2 equals 1 minus y. Y equals 3. Identity matrix. The identity matrix is the matrix equivalent of the number 1. Its symbol is the capital letter I. Identity matrix I, when multiplied with the matrix A, will result in matrix A. AA equals IA equals A. Characteristics of identity matrix. Identity matrices are square matrices, which have same number of rows and columns. It can be large or small matrices. Elements in the matrices consist of 0 and 1 only, with element 1 placed along the diagonal from the top left corner to the bottom right corner, and the other elements are 0. Inverse matrix. The inverse of a matrix A is a matrix that, when multiplied by A, results in the identity. We do not divide matrix, we multiply it by an inverse. Multiplication of matrix A, an inverse matrix of A, will result in an identity matrix, I, which is like 1 for matrices. A times inverse matrix of A equals inverse matrix of A times A equals 1. Example: determine whether the following matrix is the inverse matrix of matrix. Explain your answer. Solution: A. Matrix is not the inverse matrix. Because the product of these two matrices is not an identity matrix. B. Matrix is an inverse matrix. because the product of these two matrices is an identity matrix. Determine the inverse matrix for a 2 by 2 matrix. Determinant for matrix A is AD minus BC, where AD minus BC does not equal 0. If determinant AD minus BC equals 0, then inverse matrix does not exist. Example: for each of the matrices, determine whether the inverse matrix exists. If yes, calculate the inverse matrix. Solution: A, AD minus BC equals 1 times 8 minus 2 times 4 equals 8 minus 8 equals 0. Determinant of matrix A is 0. Hence inverse of matrix A does not exist. B, AD minus BC equals 3 times 4 minus 5 times 2 equals 12 minus 10 equals 2. Determinant of matrix B is not 0. Hence inverse of matrix B exists. Let us now calculate the inverse of B. Inverse of B equals 1 over determinant of B, which is AD minus BC, times the matrix, switch position A and D, and put negative for B and C. Equals 1 over 2, times matrix 4, negative 5, negative 2, 3, equals matrix 2, negative 5 halves, negative 1, 3 halves. Example: given that matrix D, calculate the value of M if A, matrix D does not have inverse matrix, B, inverse of matrix D. Solution: A, matrix D does not have inverse matrix, so AD minus DC equals 0. Negative 2 times M minus negative 6 times 1 equals 0. Negative 2M plus 6 equals 0. M equals 3.
B, D times inverse of D equals I. M times negative 1 plus negative 6 times negative half equals 1. Negative M plus 3 equals 1. M equals 2. Use matrix method to solve simultaneous linear equations. Convert the simultaneous linear equations into matrix form, AX equals B, where A, B, C, P and Q are constants, while X and Y are unknowns.
After that, in order to find out the X and Y, inverse of A for both left and right hand side, IX equals inverse of A times B, X equals inverse of A times B. Example: write the simultaneous linear equations in the form of matrix. X minus 2y equals 1. 3x minus 4y equals 4. Solution: write the equations in matrix form, AX equals B. After that, X equals inverse of A times B. X equals 2 and Y equals half. The concept map for Form 5 Chapter 2 is as below.
If you find this video helpful, don't forget to like, share and subscribe our channel. And if you got any question can comment below. Thanks for watching.